Hi everybody. Recently I've had some discussions on Reddit and I've seen another post and it's about the SSD trim or UNMAP for SCSI devices. It's basically the same thing, how it works on Windows. And there were some claims that actually the trim command is run on schedule on Windows and that's how it works, which is actually not correct. If you check on the internet, you will see many posts which explain how it works, how it actually does work on Windows by default since Windows 7. It's the trim command is issued every time you actually delete file. Previously it was not the case because very old SSDs, when you were lucky to have 64 gigs on them, when you issued the trim command it was serialized, which meant while the trim was working the SSD was almost inaccessible, so there was lag spikes and so on, how it worked. Well, after that, later, especially new drives don't have these issues, it's parallelized, so you can do other things while the trim is working. It's magic. So how it works in Windows actually. In Windows, when you delete file, the Windows will send the trim command saying that part of the disk is now free where the data was. Why is this important? It's important because SSDs need to know where the free space on them is, because they use the free space to write the new data. If you change some small blocks on SSD, it needs to read the data, change it, and write the new block on SSD. To alleviate and free some small spaces it has the garbage collection SSD, which works to change those small spaces, try to free up data and so on. That's what helps SSD to keep it healthy and speedy. Now, when you have some large files that you delete on SSD, you want to know the SSD that it's empty, so it has more space, it's easier to work with the data. It's not having to issue rewrite commands, it just writes to the free space that it knows that it's free. So this is why it's important to have trim. On Windows, when you delete file, it will issue the trim command, so the SSD will know that. But what happens when you do all the time deletes? Over the time, it's possible that some blocks that are actually free, the SSD things are used. Even though trim commands are used, these things can happen. So the way to fix this is the retrim command. It's not command, but it's how the Windows calls it. And that one is run on schedule. By default, it's once time a week. It's usually enough, so it helps free some small portions of the space that the trim might have missed or SSD because of the data shuffling and so on, what can happen. So the Windows trim from the scheduler command is good to have, but it's not that much important as some people believe. So you will not gain almost anything by running it daily versus weekly, since the trim is running all the time. Now, the way I'm going to show you how it works is by using iSCSI. I have a machine which serves as an iSCSI server. I have also one large file created, but it's team provisioned file on the ZFS, which is also team provisioned. Team provisioning is important because it understands trim or UNMAP command and can free up the space. Now let's first see how the configuration for the iSCSI works. It's quite simple. So I have one device here that I'm using for other things, and I created this new one which we'll use for the test. So this one is actually the Z drive here. So it's 100 gigs. Now if I go to the directory here and see what I actually have here, I have two files. One is 1 terabyte, the other is 100 gigs. The 100 gigs one is actually this Z drive here that you can see in disk management and here in disk management. But the cool thing about it is, while the size is shown 100 gigabytes, it's not actually using this space on a file system because of the team provisioning. To actually see how much it uses is using this command. So first file, while it's 1 terabyte, it's actually using 591 gigs. And the second one, which is 100 gigs, only using 269 kilobytes. If I start filling data to them, this will grow. So let's have a test to see how it actually works. Now what I will do is run a command which will update every 2 seconds to see how the size changes for this volume. I run watch command, so every 2 seconds it's run. So I have my Z drive here, and I have some test file here, Linux image, so let's copy it here and see what happens. It looks fast, but it's not that fast because of the Windows write cache. If you check the Z drive, it's still writing and the speed is dropping off. This is how the flushing for the write cache works on Windows. It starts fast and then slows down in increments by half of the speed all the time until all data is written. You can also see here how the size of the image on the disk is growing. So it was 267 kilobytes, now it's 2.1 gigabytes. So what happens if I delete this file? On a traditional disk, I would delete it, so basically pointers would remove and the data is as is in the background. On SSD, it's same as on team provision device. So if I delete now file, it's gone on the drive, it still shows 2.2 gigabytes on the image file. But just leave it there for a few seconds and see what happens. So it's still 2.2 and now it will drop to something much less. There we go, 269 kilobytes. So this is the same way as trim command on SSD does. It would tell SSD this part is free now. The same way as it told this disk device which goes over iSCSI, this part is clear and you can clear those data. So that's how it works. Now I can do this again, copy it just to see it. Let's make one more copy here, so it's more data. We see how the usage grows on the disk. The disk is not that fast, so it does take a little bit of time. You can see on Windows here on Test Manager how it's fighting still, and it's slowing down now because again how write flushing works on the Windows. So let's wait until it reaches at least 4 gigabytes, so most of it is written to this. Now let's call it good enough, 4 gigabytes, and now we can delete those files. So deleting those 2 files. The size is still here. It takes again some 10 to 15 seconds until it's actually clear. So let's just wait a little bit. It should be quite fast. And there it goes. 281 kilobytes shown, so 4 gigabytes is cleared. Same as it works on SSDs. On SSDs, it's important because of the garbage collection, and this is what keeps your drive speedy. And on team provision drives, it's similar things, so there you go. Trim works constantly on Windows. And if you have any questions about this, please feel free to post any comments and I will get back to you. Until the next time, bye.